Server actions in Next.js are pretty cool because they allow us to send post requests to our server without having to set up an API route handler and making a fetch request and all of this stuff. Instead, we just write them as normal JavaScript functions that we can call from anywhere on our front end. But because of this convenience, server actions have a lot of hidden magic going on, which also makes it easy to make mistakes when using them. In this video, I give you the 5 most common ones. Some of them are related to security, so you definitely don't want to skip on this video. And if you want to learn why you should never use server actions to fetch data, watch this video all the way to the end. Welcome to Coding in Flow. My name is Florian Walter and I make web dev tutorials that cut the fluff and get straight to the point. So if you want to learn at high speed, subscribe to my channel. For this tutorial, I've prepared a little project. You will find the GitHub link in the video description, and there will be 2 branches, one for the starting code and one for the final code at the end of the tutorial. If you want to follow along, you can clone this repository, open it in VS Code, don't forget to install the packages with npm install, and check out the starting code branch, and then you can follow along step by step if you want. Let's take a quick look at the code in here. I've prepared a fake database and the data is stored in this simple array, which contains 50 fake comments. Then I also have this dbts file, which is a fake database library. And I've written this in a way that the API looks very similar to ORMs like Prisma, for example. You don't have to understand the code in here, because in the real app you would use an ORM. Similarly, I've set up a fake authentication library, which just returns this fake user here with my name. We can call it from the server with the getCurrentUser function and from React components via this useUser hook. Again, I made this look very similar to real authentication libraries like, for example, Next.js or Clerk, which you would usually use in a real app. So let's start with our server action mistakes. Mistake number 1 is not wrapping your client-side server action calls into transitions. For this, let's start our app with npm run dev and then open it on localhost 3000. I've set up a few example pages. We go to the first one under /server/client-side action. This loads this list of fake comments, but since we use a fake database, any new comment we post here isn't actually persisted. So if we restart the app, this list will reset. We can find the page file for this under page.tsx in the client-side action folder, this one here. This is a Next.js server component, which means that we can fetch data in here directly, which we do down here in this comments list component, which has an artificial delay to pretend that we connect to a real database, and then it fetches the comments from a fake API, renders them on the screen, and we have wrapped all of this into a suspense boundary to show the loading indicator. In this comment form here, we can post a new comment, and this calls the create comment server action, which currently looks like this. To create server actions, we create a file where we put this use server directive, this string here at the top. And when we do this, every function we export from here will automatically be turned into a post endpoint on our server. So when we call this function from our front end, this actually makes a post request from the front end to the back end. The code right now is pretty simple. We send the text of the new comment and the current user to the server action. Again, we have an artificial delay in here. And then we put this new comment in our fake database. And finally, we revalidate the path. When you work with server components and server actions in Next.js, this is how you refresh the page. So after we send our comment, the server component will automatically refresh. And we see this new comment on the screen. This took a moment, which is one of the mistakes that we will fix in a second. And there are also a few other mistakes in our server action here that we will fix in this video. So if you can already see them, don't panic. The comment form component, which calls the server action, is a client component, which we can see from this useClient directive. You can call server actions from server components. You can call them from client components via this useActionState hook, which we will take a look at later. Or you can call them from client components like regular functions, like this, with no special wrapper around it. I use this client syntax often with React hook form because React hook form has to be a client component, but it's not compatible with useActionState. Let's quickly go through the code here. So we have our input state for the input field. We have this loading state, which we manage ourselves down here. And if we get an error response, then we also have this error state and we render the error in the UI. Then we fetch the current user via our useUser hook that we looked at earlier. And when we submit our form, we call our server action and then reset the input. And down here we have the form that calls this handle submit function when we submit it. But there is kind of a bug in here, and we could already see it earlier. When we post a new comment, we get a loading state, right? But this loading state resets too early, because only 2 seconds later we see the new comment on the screen. And it takes 2 seconds because I put this artificial delay into this comments list to simulate that we are fetching data from a database and from our server, which can take a moment. And this is not terrible, but it doesn't look great, right? The loading state just resets a bit too early. It would be better if it would show the spinner until we actually see the new comment on the screen. So let's take a look at our code again. What are we doing here in the comment form? We set the pending state to true to show the loading spinner and disable our button. Then we call the server action and finally reset the loading state back to false. Looks correct. The problem is this will not wait until revalidatePath has finished, until we actually refreshed the page. It will reset the input and the loading state too early. To fix this and get a proper loading state, we have to wrap the server action into a transition. And you have to do this every time you call a server action from a client component, which revalidates the path. Only this way you get the correct loading state. So let's get rid of our isPending state here. And instead we create another const, which is a tuple, so we make a pair of square brackets. Again, there is an isPending value in here. But the second value is called startTransition, and we call the hook useTransition, which is a React import. This is a React 19 hook. We delete our setIsPending calls and also the finally block down here, because now the pending state will be managed by the transition. Then we go above the try block here, inside handle submit, below set error. We call this startTransition function here. And to this we have to pass an arrow function like this. And this arrow function can actually be asynchronous. Then we cut out this whole try catch block and put it in here. And that's already it. Now the server action is wrapped into this transition. The isPending state is managed by the transition. And this takes revalidatePath into account, because revalidatePath internally does a transition. So let's save this and try this out again. Now the button should show a loading state until the page has refreshed. And there we go. Again, we are not actually saving the comments in the database, so don't worry if previous comments disappear. But the loading state of the button is now correct. But you might have noticed that the input field still resets too early. It should also wait until the page has refreshed, right? This is because this setInput back to an empty string is still outside of the transition. In order to fix this, we actually have to call startTransition in this outer transition again, right below create comment, like this. We pass an arrow function, but this time it doesn't have to be async. And in here we call setInput and reset it. This looks a bit weird because now we have 2 transitions, but this is actually how you have to do it. At the React 19 conf they showed this exact setup, and now we can also get rid of this async here from the handle submit function, because the transition function is already async. Let's save this and try this out again. Now everything should reset properly. When we post another comment, we keep the input state and the loading state until the page has refreshed, which looks much better in my opinion. So yeah, this is why you have to wrap your client-side server action calls into transitions. Now the useActionState hook I showed you earlier simplifies a lot of this setup, because this takes care of the transition and also the loading state and when to reset the input field, so we can save a lot of this code. But it's less flexible, and if you use something like React hook form, then you usually have to manage this manually. But I'll show you how to use useActionState later in this video. Mistake 2 is not validating the user input server side. So these server actions look like normal functions, which can give the illusion that we don't need validation in here, because we have arguments and we have TypeScript types, right? So we know that this is a string and this is a user object. But remember, this creates a server endpoint. So this part here happens on the client, but this part happens on the server. And just like a normal API endpoint, we can call the server endpoint from outside our app using, for example, a tool like Postman. This needs a bit of preparation, but it's possible. Let me show you how. For this, we want to call our create comment endpoint, which we do by sending a new comment from our app, right? And we also open the Chrome DevTools and go into the network tab. We send a new comment, blah. We see the request here. So this makes a post request to the same URL. This is how server actions work. But we can call this endpoint from anywhere. We don't have to call it from here, from our app. And to do this, let's copy this request URL, which is basically just this URL here on localhost. Let's paste it into Postman. We need to make a post request, but there is one more value we need. Here in the headers, we can find somewhere down here a header called next action, this one here. And we need this value. This is kind of a key to identify the server action. Then we add the same header in Postman. So this is called next action like this, and the value is this key. And now we should be able to call this server action from Postman, and we can send data in here. To see how the data should look, we can take a look at the payload. So we send the data in this array here. Let's copy this as well into Postman, and let's select raw here, and then we can paste this text. And this is the same request that we sent from the front end a moment ago. This is the comment text and this is the user data. Let's try this out. Pla2, let's send this request. Looks like this was not successful. I think we have to wrap the JSON key here into quotes because this is proper JSON syntax, and the avatar here as well. Let's try this out again. And this time it worked. We get a 200 response back, and this is the whole page here, the page data. And now when we refresh our app, we should even see this new comment on the screen because we just posted it to our backend. Now this also means that we don't have to follow any of the rules set by the front end. We are basically a neo from the matrix. So one of the rules I set on the front end is that we can only type in at most 100 characters into this input field, so that these comments don't get too long, right? But of course, when we make the request in Postman, we don't have to follow this rule. So we can add even more characters in here, send this, and break our UI. Let's see. There we go, we just cracked the matrix. This is why you always have to treat your server actions like regular API endpoints and handle validation in here. Now we can do this manually by checking if text.length is greater than 100 and then we throw an error in here. But in a real app with more sophisticated validation, you usually want to use a validation library like zot, where we can set up a schema like this one. Here we define that our comment text needs at least one character and at most 100, and we could also add other values here if we need them. And then we can use the schema in our server action. First of all, we change this text argument here. We change this to input of type create comment values, which is generated from our schema type here via this infer type, which is a feature of zot. This way we create this type that contains our text string. Then we can take this whole input and we can run it through our schema, which looks the following way. We destructure a const. We take our create comment schema here, import it, call.parse, and pass this whole input object here to it, which contains our text, so we can destructure the text value from here. The difference is that this text is now validated through our schema. And if this text does not follow the rule of our schema, so for example if it's longer than 100 characters, this will throw an error. Let's save this, then go to our comment form, because now we have to pass an object here. So we wrap this into curly braces and add the text key like this. Save this as well, and then let's try this out. Let's go into Postman. Now we should not be able to send this large text because zot will throw an error. There we go. We get a zot error because our message is too long. This way we protect our server endpoint. Now if you want to return a properly human readable error message, for example comment is too long that you can show in your UI, then you also need some special setup with server actions, which I will show you in a moment. Mistake 3 is closely related to the previous one. You might have already noticed that we are sending the user data from the front end to our server action, but again, we can never trust the front end. So we have to get rid of this here because this is not secure at all. We can't authenticate the user on the front end. We have to do this on our server. Let's save this and then go into the server action, remove the user argument here, and instead authenticate the user in here. And it makes sense to do this before we pass our input right here. Const current user. We call await get current user, which is our fake authentication function. But if you use an authentication library like Next.js or Clerk, this works the same. This will automatically take the cookie from the front end and check which user in our user database this belongs to. This is handled for you by these authentication libraries. Then usually this user is either a user object or null if the user is not authenticated. So we can check if exclamation mark current user. Then we want to throw an error that says unauthorized. And then down here for the user value, we pass this current user, which now we fetch on the server and not on the client anymore. Let's save this and check if our app still works. Works, but now the user data is fetched on the backend. Mistake 4 is not returning errors correctly. Now this is a tricky one because you probably don't expect this. Let's say we want to implement a profanity filter that filters certain words, and if we try to use one of these words, we want to show a readable error message here in the UI. So below our regular validation, we could check if text.includes, what's a bad word? I don't know, maybe Java. Then we want to throw another error that says no profanity allowed. Pretty simple, right? In our comment form on the front end, we have a try catch. And when we get an error from the back end, we read the error message, we set the error state and render it in the UI. So let's try this out. If I send a normal comment, this just works. But if I try to send something that contains the word Java, we will get our profanity error. Perfect. But attention, this only works in development. If we build our project, we will see something different. So let's stop the terminal and run npm run build. Wait until the project is compiled. And then we run not npm run dev, but npm start to start our app in production mode and not in development mode. We go to our app, we refresh the page. And then let's try to send Java again. Again, this gets blocked, but this time we get a different error message. And it says the specific message is omitted in production builds to avoid leaking sensitive data. So this error message we return from our server is stripped away by Next.js for security purposes because you don't accidentally want to leak sensitive data here. Because this is code running on your server and you don't want to leak this to the front end. If we want to return a readable error message to the front end, we have to be a bit more explicit and return it as a string. This could look the following way. We could set a return type of this function to a promise because this is an async function. And in this promise will be an object that contains an error. But since we don't always want to send an error, let's say the promise can also contain undefined. And now instead of throwing an error down here, we return this object that contains this error as a string. And otherwise, if we create a comment successfully, we don't return anything. And we also want to move our whole try catch in here. So we want to wrap all the content of this function into try catch. So now this is wrapped into this try catch block. And if we throw any other kind of error like unauthorized, we get to this catch block where we will log the error to the console. And then again, we return an object with this generic error message, failed to create comment. So we have two different kinds of error messages, either no profanity allowed or failed to create comment, which includes all the other errors. You always want to distinguish between expected errors and unexpected errors. Our profanity filter is an expected error because it's likely that a user uses the word Java and then we want to tell the user what they did wrong. But authentication, for example, is an unexpected error because we should never call this endpoint without being authorized in the first place. So instead of returning unauthorized, we return this generic error message down here. But this is personal preference and it depends on your app. Or if something else in here goes wrong, like our input validation right here, it will also go down here and return this generic error because again, this is an unexpected error. This should never happen. This one can happen from time to time. So we want a more specific error message here. Then we have to go to the comment form and into our handle submit function. Now we can get rid of the try catch block here because our server action doesn't throw errors anymore because it's already caught in here. It only returns an error object. So we get rid of the try catch in the comment form, the catch block as well. And instead the create comment function returns a response, which we can store in this variable. And there is still one curly brace too much here, should be this one. And in this response is now our optional error, right? So below we can check if response.error, which can be undefined, so it adds the save call operator. Then we want to set this error message here. So we call set error, but this time the error is already a string, so we can set it to response.error to show this error in the UI. And important, return below so that we don't reset our input if we get an error. Let's save everything and try this again. So again, we build our project with npm run build. And then we started with npm start. And now we should see our error message in the UI. So when we try to send Java, we see no profanity allowed. Perfect. Now again, the useActionState hook, which I also added to this example code as another page, makes a lot of this easier. It automatically handles the transition, it resets the loading state and the input field at the correct time, and the code is more concise, but at the same time it's less flexible. You can't really use this with something like React hook form, because this is based on form data and uncontrolled inputs, which doesn't work with all the other tools in React. Nevertheless, I added this as an example so that you can see the difference. The server action also has to be written a bit differently than our previous server action that's compared it to. Let's put this on the right side. So the useActionState server action can't accept these resolved values like our dot values here. Instead, it has to accept form data and also this pref state here. Form data is a bit more awkward to work with from my experience, but it's this old school HTML value that has been around forever, and I guess they use this to adhere to these web standards. One benefit of useActionState is that it works without JavaScript. So if we enable JavaScript here, this would still work, but it's very rare that someone uses your website without JavaScript. It will probably never happen. Another change is that here, in the useActionState server action, we have to return our input again because useActionState automatically resets this input field. We don't have to do it manually like we did before. Here it happens automatically. And to avoid this, we have to put this input text into the state and then use it as a default value here. I don't want to go into much detail. If you want to see a dedicated tutorial on useActionState, write a comment and leave a like on this video. If you want to see the code, check the repository in the video description, but all the other stuff I mentioned before, like handling validation and returning error messages, works the same for useActionState. You still have to return these readable error messages, you still have to do the validation and authentication on the back end. The only difference is how you use these actions on the front end. Mistake number 5, and this is a big one, is using server actions to fetch data. For this I've added another example. This one also shows our comments list, but this time with infinite loading. So down here we have this load more comments button, which loads the next page of comments again with an artificial delay, and so on until we reach the last page, and then we won't see this button anymore. I implemented this using React Query, but I won't show you how exactly I did this because I have a dedicated tutorial where we build pretty much the same comment list. Just search for Coding in Flow React Query on YouTube and you will find it. And when we get to the final page, the load more button disappears. We can still post new comments, and I've added this code to the sample project. Let's take a look into the server actions file. This one is a bit different. We still do all the same validation. We still have to return error messages as strings, so they are readable on the front end, The difference is that now after creating a comment, we don't call revalidatePath at the end. Instead, we return this new comment because this page is not a server component anymore. This is a client component, and here things work differently. Instead of refreshing the page, which only works for server components, we take the comment that we get back and put it into the React query cache. Again, I explained this in my React query tutorial. For this example, you don't have to understand this in detail. But instead of revalidating the path, we return the comment that we just created. The return value is also slightly different. I created this action result type because we have to return this comment. So now we not only have an error object in here, but also this data object. And we either return data or we return an error. This is why we have these question marks here. The other value is always optional. So now we can return data new comment, or we can return error with the error string. The mistake is happening down here. I set up another server action where we fetch comments. This one is called getComments. We set a page size. We have a pretty big artificial delay. We fetch the comments from our fake database, set up the cursor, and return all of this to a React query. Again, this is explained in my React query tutorial. We call the server action in this useCreateComment hook, which uses a React query mutation to post this comment. We handle the data and the error that it returns. And up here we have the useComments hook, which uses useInfiniteQuery from React query to fetch our comments in pages, as you saw a moment ago. And you also saw that this seems to work fine. We can load our pages, even though we are using a server action. And remember, server actions are post endpoints, but to fetch data we should usually execute a GET request and not a post request. But this is not idiomatic, but who cares, right? Because it works. So it doesn't really matter if it's a GET or a post request, and only web dev nerds would care about this. But there's another problem. These server actions run successively one after another. And because of this, if you use them to fetch data, you can slow down your app. We will notice this when we try to send a comment while loading a page at the same time. So let's refresh the page. And here in our server actions, we have a delay of 4 seconds for both the create and the get comment functions. So we have a pretty big delay in here. So now when I send a comment, it should take 4 seconds until it pops up on the screen. 1, 2, 3, 4. There it is. Nothing special so far. But if we first load the next page and then immediately try to send a new comment, it will first wait for this server action to finish before it executes this one. And this is a problem. So let's try this again. I will click the load more button, and then I will immediately click the post button. And now we have to wait 1, 2, 3, 4. So overall it was longer than 4 seconds because we first had to wait for this page to finish loading. And if you have multiple things going on your page, then this can really slow down your app and you have no idea why. But the reason is that server actions always run successively, one after another. So when we click this button and then we send a new comment, it will first wait until this page has fetched, because both of them are server actions. The simple solution is to not use server actions to fetch data. So creating or deleting or updating a resource is fine, but you should not use these actions to get comments. So we delete this. And what should we use instead? An API route handler, which is a regular server endpoint that we can create in Next.js like this. We create a new folder inside the app folder called API. Then we give this route a name, for example, comments. And in here we put a route.ts file. I'm gonna copy paste the code that does the same as our getComments server action did earlier, just in this route handler. Again, I explain all of this in my React query tutorial on YouTube. These route handlers are not queued up like server actions. They can run in parallel. And lastly, we have to go into this useComments hooks file because we don't have this getComments action anymore. Instead, we have to make a request to our endpoint, which is a bit more verbose than just calling the server action function, but it's necessary. And it can look like this, for example. I use Kai, which is a wrapper around fetch, but you can also use the normal fetch function here, but Kai is a little bit better. We call the server endpoint, we send the cursor there. Again, this is React query stuff. Let's import this. But now we don't call the server action anymore. Instead, we fetch the data from this endpoint. So let's save this and try this again. And now this should work without this extra delay. So again, I'm going to send a comment, which will take 4 seconds, but this time we don't have to wait until this page has fetched. 1, 2, 3, 4, and our comment is there. It didn't wait for this page here to fetch first. This is what we want. And this is why you should never fetch data in server actions. If this video was helpful, please leave a like and subscribe to the channel. And as a reminder, I have a free React Best Practices email course, which you can get at codingandflow.com/React Best Practices. If you liked this video, then you will also enjoy this free course. Then I wish you a lot of fun, happy coding, take care.